Alright, let's quickly go over this video on limit. Welcome to this lesson. This is a limit 0 of e to the power of x minus 1 divided by x, and again we have been asked to limit this function to 0. So the first thing we always do here is that we test the value 0 and see what it gives us. So let's see what the value 0 gives us when we test it. So limit as x tends to 0 of e to the power of 0 minus 1 all over 0. So what we know for sure is nth value raised to the power of 0 is 1 minus 1 over 0. This is equal to 0 over 0, which we call the indeterminate form. Indeterminate form. So after we experience this, what we do next is that we look for alternative, and one of the alternatives is the L'Hopital's rule, and you are only allowed to use the L'Hopital's rule only whenever you get the indeterminate form. But in this case, you can also use a rule called the Taylor series expansion for the exponential to the power of x, or you can use the L'Hopital's rule. But in this video, I would like to show you both methods for your own understanding. So let us use the Taylor series expansion, or the expansion for this man here. So let us do that. So the Taylor series expansion for e to the power of x, and that is e to the power of x is equal to 1 plus x plus, are you following me, x to the power of 2 over 2 factorial plus x to the power of 3 over 3 factorial plus x to the power of 4 over 4 factorial plus so seeing this, we can actually manipulate our way in and get what we need. So our goal is to arrive here and limit the right hand side. If we can manipulate our way in and arrive here, then we can limit the right hand side and get our result. So let's go. So we observe that here we have e to the power of x minus 1, so we can bring this one here to make that happen. So we have e to the power of x minus 1 we have this left, x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the power of 4 over 4 factorial plus dot dot dot. So now what can we do again? We need x here, so let's divide through by x. So this by x, we are dividing through by x because we need x there. So excuse me, so we have this, and we are dividing through here also by x. If you do that, you know that this is already this, so we can simplify by saying x here, x in all will give me e to the power of x minus 1, all over x is equal to x in x here 1 plus x over 2 factorial plus x squared over 3 factorial plus x to the third over 4 factorial plus dot dot dot. So this is what I have in return. So I can apply limit to both sides. If I apply limit to both sides, I get limit as x goes to 0 of e to the x minus 1 all over x equals to limit as x goes to 0 of 1 plus x all over 2 factorial plus x squared all over 3 factorial plus s cubed all over 4 factorial plus dot dot dot. So we have that. So you observe that this question, oh sorry, excuse me, our question here is already what we have here. So let us limit, let us put our x as 0 to c. So our limit as x goes to 0 of e to the x minus 1 over x, sorry, divide this here, over x is equal to, if we put 1 is unchanged, plus 0 over 2 factorial plus 0 squared over 3 factorial plus 0 cubed over 4 factorial plus dot dot dot. We have that. So the limit as x goes to 0 of e to the x minus 1 all over x is equal to, this goes to 0, 0, and the answer is 1. So the answer to this limit by using the Taylor series expansion is 1. So let us solve the same problem using the L'Hopital's rule. This implies that as x tends to 0, this entire function tends to approaches 1. So let us also use the L'Hopital's rule to solve this problem. So let's go using the L'Hopital's rule. Using the L'Hopital's rule, so we have limit as x goes to 0 of e to the x minus 1 all over x. So the L'Hopital's rule says we should apply derivative to the function and differentiate it independently, that is each component independently. So we have dx applying to the entire function x goes to 0 of e to the x minus 1 over x. I think that is the idea here. And if that happens, e to the x, how do we differentiate e to the x? To differentiate this, if y is equal to e to the x, and you want to differentiate this, all you have to do, the formula you have to use is e to the u dot u prime. This is one of the formula that you want to use. Yes, this formula, e to the u dot u prime, because we are going to make u equals to x here, so that y is equal to e to the u. If that happens, then we can say u prime is equal to x, and the formula is e to the u dot u prime. So dy dx is equal to e to the u dot, sorry, u prime here is 1, so e to the u dot u prime. So dy dx of e to the x is simply e to the x, nothing changes. So we'll put it there. So we have limit as x goes to 0 of e to the x minus 1 all over x. After applying the derivative, even applying it, d dx is equal to e to the x still remains e to the x minus 1 goes to 0 and x goes to 1. X goes to 1. So this is the answer. So we have this left. Limit as x goes to 0. As x goes to 0 of e to the x. Now, all we have to do is put x at 0. By putting x at 0, we have e to the 0 equals 1. So limit as s tends to 0 of e to the x minus 1 all over x equals 1. Also by using the L'Hopital's rule. Yes, so you can go over this video, watch it as many times as you like, and kindly like and subscribe as you watch the video. Thank you. See you in the next video.